Now that we've seen the area formulas for rectangles, squares, and triangles, let's move on to another unique type of quadrilateral, the parallelogram, and a special formula for a rhombus. So what I'm going to ask you to do first is to pause the video and ask yourself, how would you find the area of this particular parallelogram? If one set of sides is 25 feet long, another set of sides is 10 feet long, and we know that there is 8 feet that separates the two 25-foot long sides. Maybe you already know the area formula for a parallelogram. If not, see what you can do to manipulate the figure here. Come back when you are ready to actually see this manipulation, see the area formula, and move on. Well, there are several different ways you could do this. One potential way is to try to do the same thing on the right side that we did on the left side and draw the altitude, without moving that, and draw the altitude from the bottom base up to the top base and see if these two triangles here are congruent. Spoiler alert, they are. So this is also 6 feet, this is 10 feet, and this is 8 feet. Now we have two triangles and a rectangle that we know how to find the area for. Or we could also think about it as though we could take this triangle over on the left-hand side of the parallelogram, and because those two triangles are congruent, move it over to the right side of the parallelogram. We know that those sides are congruent, we know that those angles are supplementary, and we can actually think about it as moving one part of the parallelogram over to the right-hand side, and now we have a rectangle with the same dimensions. And both of those ideas, the idea of cutting the parallelogram into two triangles and a rectangle, or just taking one piece of the parallelogram, sending an altitude from one base to another base and moving it over, gives us two different ways to talk about the area of a parallelogram that both end up with the same formula, and that is the area of the parallelogram equals base times height, where the base is the length of one of the sets of parallel sides, because both sets of parallel sides are congruent in a parallelogram, and the height is the length of the perpendicular segment connecting the two congruent bases. So go ahead, pause the video, copy this area formula down, come back when you're ready to do some example problems. So in this particular parallelogram, in order to find the area of it, where we have base times height, we literally just multiply the base length, which is 25 feet, by the height length, which is 8 feet, to get 25 times 8, or 200 square feet. And the area formula is as simple as that. Remember that the height must be perpendicular to the base, the same way that the height and the base must be perpendicular to the area formula for a triangle. So in this set of example problems here, go ahead, pause the video, find the area of these two parallelograms, come back when you're ready to see the answers, and move on to a special area formula for rhombuses. So I've given you a little bit of extra information. You don't actually need all the information that I have here, but it's designed to make sure that you are looking at the correct things. The area formula is base times height, but base times height must be perpendicular. So that in number 1, over on the left, what we're looking for is 20 times 7, which gives us an answer of 140 square kilometers. That 8 is not perpendicular to 20, so that 8 is not a part of the area. In number 2, we're looking for 16 times 21. And 16 times 21 gives us 336 square meters. Again, our units are squared because we have 16 meters times 21 meters. So those are the areas of those two parallelograms. Again, be very careful that you are not tricked into using the other side of the parallelogram. That's an important piece of information, but not relevant to the area. If we have rhombuses, the fact that their diagonals are perpendicular means that we can actually come up with another formula for the area of a rhombus. Of course, we can use base times height just the same way we can for any other parallelogram, including a rectangle, but the diagonals are perpendicular, and that splits this rhombus into 4 congruent triangles. And so if we take the area of just one of those congruent triangles, that is 1/2 d2 times 1/2 d1, all times 1/2, because the area formula for a triangle is half of base times height, then each of those triangles has an area of 1/8 diagonal 1 times diagonal 2. And since we have 1, 2, 3, 4 of those triangles all together, the total area of this rhombus is just that times 4, or 1/2 of diagonal 1 times diagonal 2. Go ahead, pause the video, come back when you have copied down this area formula as well as the diagram and are ready to do 2 practice problems to end the video. So in this case, if we knew diagonal 1 was, let's call it 6 inches, and diagonal 2 was 8 inches, then the area of this rhombus would be 1/2 6 times 8, or 24 inches squared. Because again, that is 1/2 6 times 8. So it's important to note when you're working with parallelograms and rhombuses that you can't merge the 2 formulas together. If you have a rhombus, you can use 1/2 diagonal 1 times diagonal 2, or you can use base times height. Either works, but you can't take a diagonal multiplied by the base and somehow come up with an area formula for it without doing a little bit of extra work. It's entirely possible that you could use them to find the area. In fact, you can use them to find the area, just not straightforward with either one of these 2 formulas. The idea of using diagonals and bases and heights need to be kept separate. So last thing for you to do in the video here is to find the area of these 2 rhombuses, and pause the video, find those areas, come back when you're ready to see the answers, and do a quick review to wrap the video up. So again, the area formula is 1/2 d1 times d2. So in the rhombus number 1, it is 1/2 6 times 4.5, which gives us an area of 13.5 square centimeters. And the area of number 2 is 1/2 11.5 times 7 inches. And so when we go ahead and multiply those 2 things together, we end up with an area of 40.25 square inches. Because 11.5 times 7 is 80.5 divided by 2 is 40.25. So quick review, the area formula for a parallelogram generally is base times height, where the base and the height are perpendicular. You can use either of the sides as the bases, or either sets of parallel sides as bases, as long as you find the appropriate height. And the special area formula for a rhombus is 1/2 the product of the diagonals.